Hi, today we're going to figure out which integer values the zeros of this polynomial fall in between. So to do this, we're going to first check our basic integers, -3, -2, -1, 0, 1, 2, 3, to start with to find these zeros. So how are we going to check these? Synthetic division, because it's really fast. So we put our -3 in the corner, and we put our coefficients, and as you can see, we don't need any placeholder zeros. So we have -3, 5, 4, 4, and -8. And then we draw our line. We bring down our 3, so that's -3. And we multiply, that's 9. Add 14. Multiply, -42. Add -38. Multiply, that is 114. Add, that's 118. Multiply, -354. Add, that is 362. So we have the point -3, -360. Why did I write that? 2. Next, we're going to check -2. So -2 in the corner, and we have our coefficients again. Draw our line, bring the 3 down. That's 6, 11, -22, -18, 36, 40, -80, -88. So we have -2, -88. Next, -1, -1. Have our coefficients, -3, 5, 4, 4, -8. Draw our line again. Thicker line. Bring the 3 down, -3. Multiply, that's 3, 8, -8, -4, 4, 8, -8, -16. So we have our -16 right here. And if we clear ourselves a little bit more room, well, first of all, before we go on to the 1, we can obviously see what f of 0 will be here, because if we plug in 0, we're just going to get -8. So we don't even have to bother doing synthetic division for that. So this is going to be -8. And so for 1, we don't need to use synthetic division for that one, because we see that we just add up the coefficients. So -3 plus 5 is 2, plus 4 is 6, plus 4 is 10, minus 8 is 2. So 1, 2. 2 using synthetic division is, first we write down our coefficients, draw our line, bring down the 3, -3, multiply, it's -6, -1, -2, 2, 4, 8, 16, 8. So we have 2, 8. And finally, 3 here, -3, 5, 4, 4, -8 with our coefficients. Draw our line. -3, -9, -4, -12, -8, -24, -20, -60, and then -68. So we have -68 here. So we have all of our values, and so we're going to use these values to start graphing. So now it's time to start graphing, and we have our axes drawn right here, and we have all the points that we need in our table. And so first we're going to start off with -3, -362, so -3, and then -362 is simply a very negative number for our purposes. This graph isn't going to be proportional, but it's still going to tell us exactly what we need to know. So -2, -88, let's say it's right there. -1, -16, 0, -8, 1, 2, 2, 8, and 3, -68. And like I said, it's okay that it's not proportional, because it tells us whether the y coordinate is positive or negative. So That is what we get. And so since this is a fourth degree polynomial with a negative leading coefficient, we know that its end behaviors are going to be towards negative infinity here and towards negative infinity here again. And so we know that we've drawn the end behaviors correctly. So back to the question, where do we see zeros on this integer graph? Well, in between 0 and 1, we see that we cross x-axis. So the 0 must lie in between 0 and 1. And also, it must lie between 2 and 3. And there may also be zeros, like, for example, if we had this, and it's just like that, and this was an integer, and this was an integer. But we're only in charge of the integers here, so this is completely fine. And so our answer is that the zeros are between 0 and 1 and 2 and 3. We know that this polynomial will have 4 solutions, either real or imaginary, but if we look at our integer graph here, we're only responsible for the 2 that we can see right here, which is in between 0 and 1 and 2 and 3. So that's the answer.